Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
There's a great deal of work being done in the arena of orbital manufacturing. Many of the companies working to place private space stations in orbit say that manufacturing is one of the functions that can make them commercially viable. Aboard the ISS, several additive manufacturing or 3D printing processes have been studied. And my guest on this edition of the Ex Terra Podcast is Ryan Elliott, co-founder and CEO of In-Orbit Aerospace, a company building the orbital infrastructure to create new and improved products in microgravity and deliver them back to Earth. Ryan, welcome to the program.
Thanks for having me, Tom.
So let's just start with the basics. Why manufacture things in space rather than on Earth?
Well, we can make entirely new products, and even ones that are way higher quality than we can make on the ground. You get rid of a lot of physical phenomena that happens on Earth, such as turbulence and convection that can create defects in structures. So when we go to space and we manufacture, we could create new pharmaceuticals. We can cure diseases that we can't cure here on Earth. We create new semiconductors, optical fibers, and a whole host of other materials that are waiting to be discovered.
So let's talk about the concept then behind Orbit Aerospace.
So we want to be the third-party logistics provider for manufacturers who want to make these products in orbit. So we provide them the transportation, the power and the data, and the return back to the ground. So we can fly independently with our spacecraft. We can take them to crewed space stations, or we can take them to uncrewed platforms as well.
So when you're talking about, using the spacecraft to get people and their manufacturing stuff to other space stations, are you also providing some kind of a manufacturing process, or do you just take them and their gear and send it up into orbit?
Yeah, the latter. So right now we primarily work with people who have operated in the ISS already. They have hardware that does these kinds of activities and performs these kinds of processes. So we are just the space for people to take their stuff to space.
Are you thinking about you might be able to go to ISS before some of these private space stations are ready to be able to work on some of these processes?
We definitely really like to. And we've submitted proposals before. It is a huge task to get a vehicle certified to fly to the ISS and to be able to depart. So there's some additional logistics that need to be carried out. But once we perform, our first mission and we have kind of a high success rate and lower risk that something would go on, it's definitely something we'll be looking into next.
So I'm guessing you're not planning on building human-rated spacecraft. You're just talking about basically trucks to shuttle gear up to whatever it is that is going there. And if they need personnel, they have to go with somebody like SpaceX, who has a human-rated spacecraft, to be able to get their people there as well.
Yeah, exactly. We can at least provide a pressurized environment for certain types of biological experiments, but we wouldn't want to carry any crew on board. You could fit a human inside our payload bay, but yeah, I wouldn't recommend it.
It'd be a rough ride.
Yeah, very.
Ryan, talk about your background a little bit and how you decided this is the company you wanted to create.
Yeah, sure. Yeah, this is actually a story that goes back nearly like 10 years. I did an undergrad in physics. I got my first job at an internship I was working at the Kennedy Space Center Visitors Complex. The company was called Atlantis Educational Services, and we taught space camp. You go to space camp as a kid. I never knew that you could teach it, but that happened. So we were building and building rockets, building robots, doing a lot of really awesome stuff. And we were teaching kids about the wonders that go on the International Space Station. So it was a really great opportunity to be there. 2013, 2014, SpaceX was just starting to launch a whole bunch. It was a real vibrant time on the Space Center there. And that's where I got my passion for space in general. We were hosting a competition for a bunch of young students. It's called International Space Settlement Design Competition. And a couple of the people that were advisors worked at NASA. We went out to dinner with them one night. One of them had worked on the ISS and the space shuttle. I think multiple of them did. But we were talking about the space shuttle as well as the X-37B, which is a space plane, but slightly smaller. I think it was designed to fit inside the shuttle. And I was just kind of out of curiosity, like how small could the space shuttle be? And this guy holds his hands out like the size of a loaf of bread, just immediately snaps them out there, no question behind it. And I was just like, I was in awe. I was like, somebody needs to go build some like really miniature, CubeSat style space shuttles, and well, it's going to be me. So I hopped out of there. Decided the transition plan was to go to grad school and then get into the industry. I went to the University of Leicester and studied space systems engineering. We did a grad project on lunar and Martian exploration. It was really, really fantastic program. Took me kind of like to a few other countries as well. But the other half of our cohort did one on a successor to the ISS. And this was sponsored by the European Space Agency. So it was these kind of two overlapping concepts that it could be technically feasible to build a very small reentry vehicle, and that there's a government space agency that's interested in furthering options and accessibility for research and manufacturing in space. So I got out of grad school, and these two little seeds are kind of like planting and tangling themselves. And there's like one more missing part. Do people on the ISS want other options, and are there things that you can make in space that would be good business models? Could you close it? And so I grabbed a colleague that I went to grad school with, and we started looking into it and talking to people, and the answers for both of them were just overwhelmingly yes. We did eventually find out that just a small space shuttle that would ship CubeSats might be a little too small, and that business model wouldn't close. But if we went for something that was slightly bigger, there are loads of materials we could make that had great unit economics. And now that the space industry is turning, the launch costs and the hardware availability makes it so that we could operate an independent service for hosting research and manufacturing in space. So this brings us to about 2019, 2020. We decided it was time to go. We brought in another friend of my colleagues who he'd known since like high school, who had done fantastic work working on space programs with NASA, such as James Webb Space Telescope and Lunar Reconnaissance Orbiter, and we went to work.
So what kind of business background do you have? I mean, obviously it's cool to build hardware, but it's a business as well. Do you have some kind of a business background, or you have someone on your team who basically handles the business end of it?
We have some advisors that have that expertise. They give us all of the expertise that they've had and all of the advice, but over the last like 2 years, it's something that we've had to learn. So now as CEO here, that's primarily my job.
And what's that learning curve been like? Is it what you expected to be able to run a business when you were basically a tech guy that wanted to build something cool?
Yeah, I don't know if I ever actually had expectations about it. I mean, it's definitely different. You really do have to get good at delegating work and just stepping back, and it does get nice when you get used to it to be able to tell people what to do. Not exactly like that. We work together with each other, but like I can trust that the people on our team can get it done. And when you are able to build those types of trust relationships, it's freeing, if you will. So I think the difference is managing a much larger network than I ever had. Working at engineering firms, I worked at SAIC at a small company called FinCom, and also like a Raytheon for a little bit. And you work with your team of engineers and some external partners. Depending on your level, you might work with tens of people. And now there are hundreds of people that I have to like interact with and maintain relationships with. So that was definitely a hard part. Also trying to explain manufacturing in space to a general audience has been, that was our learning process to begin with, to get just the general public to understand the benefits of it and why it's something we should care about. But that's been coming around pretty well.
So you're finding some acceptance for the concept among the general public, that they say this is something that, maybe not necessarily the government should be spending money on, but that should be explored and developed and is a worthwhile project.
Absolutely. This isn't exactly something new. We've known that we could make better products in space since Skylab. They had a semiconductor experiment up there. It's just that the way the space industry has gone has been mostly government funded, and the primes have been the one building the spacecraft and also the space stations. So now, obviously, that's part of the reason we're here, is that dynamic is changing. And today we have artificial intelligence and machine learning, we have quantum computing, we have nuclear fusion, we have self-driving cars. So, in-space manufacturing is just a facet along a similar vein.
What applications, you've touched on this a little bit kind of in broad terms, but be a little bit more specific about the applications you foresee for your technology.
Yeah, definitely. So if we're looking strictly at manufacturing materials, I'll give a few examples. One that probably has the most heritage is optical fibers. There's a specific glass called Zebalan. That's an acronym for the elements it's made out of. I won't name them all here, so I'll stumble over them, zirconium, et cetera. But we can make it on Earth, but it's not very good quality. You actually get crystals in your glass fibers. You're pulling it due to a variety of reasons, such as the convection and messing up as the melt crystallizes. And that makes it a worse fiber. But it theoretically has a better transmission coefficient than silica fibers. And the use case for this is laser applications, as well as the transoceanic cables that let us talk to people in other countries. So there's hundreds of millions of kilometers of fiber produced every year. And this fiber can replace the oceanic cables. It can make better lasers. It can do a whole lot. If we make it in space, we get 100 times better quality. And then because you can get tens of kilometers from a single kilogram of glass, unit economics works out really, really well. So another one would be protein crystals. And the same here goes for a lot of crystals, and loads of different materials have crystal structures. So protein crystals can be grown in much, much larger sizes. And that allows us to do X-ray crystallography and determine the structure. That structure allows us to learn more about how the proteins work, what the structure is, and how we can either use them to cure diseases, or if they are something, we can create better medicines to help work and interact with them. We can also grow stem cells in different ways in space. They'll age 10 times faster than they do on Earth. So if we can figure out why they age differently and what the mechanisms are behind that, we can all be young again. And going back a little bit to the crystals, there's also semiconductors. We can not only create different types of semiconductor crystals in space, but it's also been shown that you can just bring a low-grade wafer to a microgravity environment, cycle it through temperature and pressure, and it would effectively anneal itself to a higher grade wafer. So these are some of the big three kind of industries that are of interest today.
So where do you envision your starting point? What do you think is going to be your first payload?
So we have recently signed an initial agreement for a customer to fly in our first mission, which is really, really awesome. We'll have kind of like a press release event, so I don't want to spill the beans just yet. But they will. I know. I wish I could. Yeah. But they're going to be doing a biotech experiment growing organoids from starting with a small subset of stem cells and taking some images of those to see how they look. And then we'll be bringing them back. So that mission is going to be October of next year. We're really excited about it. All of the kind of pieces are in play with the suppliers and also the launch vehicle and the host satellite provider. So we're just pushing forward towards that.
So how do you get to orbit? Are you building your own spacecraft, or are you going to be riding on one of the commercially available launch vehicles now?
Yeah, we're definitely not building a rocket.
It's been done.
It has been, yeah. I do applaud the people that are going for that. Our spacecraft are definitely much smaller than a lot of other kind of spacecraft too. So we can ride share on a variety of different vehicles as well. This first mission will be on a SpaceX Falcon 9. In the future, we hope to be able to fly on at least a dozen different types.
And then what's your reentry vehicle like? How does that work? And what are the challenges?
Yeah. These initial ones are just going to be basic capsule types. Okay. So we have the big blunt heat shield on the end, the general cone shape. The first ones are about 1.2 meters in diameter. And we will build bigger ones eventually, but right now we see that as a size that can accommodate a wide variety of experiments and kind of suit the demands of the upcoming future. So earlier challenges were just trying to find the heat shield material. Like, there's only a few people that build those. There's only one American vehicle that operationally and routinely goes to space and comes back, and they make their own heat shield. So also the dynamics of it, like, it's an extremely unforgiving environment. Not just space, but reentry. You're coming back at 25 times the speed of the sound. You're ionizing the gas in front of you. There's literal chemistry going on because you're at such a high hypersonic speed. So not only is that obviously dangerous thermally for the aircraft, it's also a very dynamic environment as far as the aerodynamics and stability goes. So you need to make sure that your vehicle is kind of near perfectly tuned to that.
Right.
The FAA has a very, very strict regulatory process. You do not get back from space unless you have like a 1 in a million chance or less of injuring somebody.
I'm talking with Ryan Elliott, co-founder and CEO of In-Orbit Aerospace on the Ex Terra Podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. So, what details can you share about the platform you're developing? I know it's a proprietary platform, but can you give us any details about what it is that you're actually building?
Yeah, so there's a few pieces to this, actually, and then we won't be deploying them all in our first mission, but we'll have obviously a roadmap that leads up to that. The first piece is the reentry capsule. The first one that we will launch will be about 20 inches in diameter. The second one, which will be the line of vehicles that we fly, will be about 4 feet, 1.2 meters in diameter. There's an internal payload bay. This full-scale one will be able to fit a couple hundred CubeSats in volume, or mid-deck lockers, which is a current standard for payloads on the International Space Station. The other parts are an orbiting satellite that we would procure. So this would be the uncrewed satellite that provides power and data to the customer payloads. And the third part of it is what we're calling our resource exchange module. And this is something that we've built in-house, and this is kind of the proprietary differentiator. That serves to host customer manufacturing labs on the satellite. It also is what hosts the payloads in the reentry capsule. That is the part that allows these two spacecraft to dock together and exchange materials as well. So what we see is if we have to take astronauts out of this equation, at least when we're doing uncrewed experiments, ones that don't need people or you don't want people on them, we do need to do what they do on a base level. And that would be to take payloads out of the visiting vehicle, put them in their rack, and vice versa. So similar to that, we can also just bring up raw materials and just bring down finished products, which would be very, very favorable to people who are paying for every kilogram they ship.
Sure. So Ryan, the race for orbital manufacturing is really heating up. There are companies like Aerospace, Orbit, and Varda. What competitive advantage do you bring to the market?
I would say it's a couple things. The first is there are a lot of companies that are looking at building certain, like very innovative and very novel type of reentry systems or technologies. And I do love innovation, but I think the innovation of today for this industry is just getting vehicles to space and back. That doesn't happen right now. That is novel in itself. Right. So we are currently going to start by using qualified hardware and systems that have flown to space already. So we want our customers to know that they will get their stuff back when they fly with us. So there's a big emphasis on reliability here, and that's a challenge in itself. But the second one is this resource exchange module I was speaking about. Just being able to autonomously and robotically transfer payloads in space is a pretty big deal, not just for manufacturing, but for the future of the space industry itself. So what we're building is very akin to basically the conveyor belt of space. Can't use a conveyor belt in space because, well, there's no gravity up there. So when it comes to manufacturing, being able to sort and store and transfer payloads between two spacecraft is really beneficial because when launch costs are $10,000 and dropping, and the cost of these materials, you could sell them for $100,000 a kilogram or more. We want to let people make more products. That's the part that matters. They want to bring back the product they're producing. They don't want to bring back the manufacturing lab if they don't need it. And we don't need to bring back additional hardware if it can stay on orbit. So we are reducing costs by reducing the general weight of our capsule, allowing some stuff to stay in orbit. But primarily, we are increasing the capability of manufacturing and researching that can be done in our vehicle by only taking up the research and the products that matter.
Does your business, I'm sorry, go ahead.
I was going to say this same capability can also be used in crewed space stations as well, because astronauts, there's going to be so much more that they can do on space as these other space stations come online. I think autonomy can also be included in crewed space stations as well. So
does your business model include potentially long-term clients where on the first mission you send up their manufacturing facility, and then in subsequent missions you just send up additional raw materials, and their factory, for lack of a better word, stays where it is and it continues to work on a long-term basis?
Yeah, exactly. Yeah, at some point in time, we really, that's when we can enable the 3PL model of in-space manufacturing and hosting. So stations that don't just host one manufacturing lab, but multiple manufacturing labs. And you can log into your computer and go, I want my products down right now, and pay a premium. Or we say we have this scheduled delivery coming back down. And because of our cargo transfer, our conveyor belt technology, we can aggregate products from 5 to 10 different customers and bring that down on a schedule, lowering costs for all.
It's like Amazon Prime. If you want it now, you have to pay a little bit extra.
Exactly. Yeah. You can sign up for the in-orbit Prime membership as well, and we won't get into that.
Is it getting easier, though, to put space systems together as there's a developing supply chain to invent, manufacture, and support various subsystems? Or is it still a lot of custom design that's required?
There is a lot of custom design still for various different pieces, but you could get different suppliers to build every part of your spacecraft for you, especially when we're talking about CubeSats. You could just tell somebody to build you a CubeSat, launch it, and then say that, our company got to space. Sometimes people do that. Because we're not building something that's the general CubeSat shape, it has that form factor. We do have to do some custom engineering in-house, but the avionics and the hardware, a lot of that is definitely off the shelf. Our heat shields have to be custom, at least the geometry of them, and of course some of the general structures and parachute systems are hard to come by, but there are suppliers for those as well. So
You have a quote from NASA astronaut Chris Cassidy on your website that your, quote, unique approach will simplify operations for dozens, if not hundreds, of future space companies. What's unique about your approach to space manufacturing?
I would say, again, it's the ability to transfer material between two spacecraft. It's going to be useful in the future as well, just not for in-space manufacturers. It could be useful now for people who just want to test hardware. We can bring your hardware up, we can test it, we can operate it, we can bring it back down. You can refly it on another flight, or perhaps you can make some upgrades to it and fly it again. Then as time goes on, right now we're talking about in-space manufacturing and bringing it back to the ground, but orbital manufacturing is another hot topic. When we're going to build massive spacecraft, or maybe we want to be a little bit more efficient in just bringing up the materials for spacecraft and producing them there, we're going to kind of have that infrastructure in place to move products around and enable people that want to build the general components to get their raw materials in there and then aggregate them together on assembly platform. So I think there's a lot of use cases and there's a lot of longevity for the technology in orbit's developing.
You touched on this a little bit, but I want you to be able to give props to some of the other members of your team. Who are you working with?
Yeah, so on our team, my two co-founders, Ishan and Antonio. I met Antonio in grad school. He's known Ishan since high school. They're extremely great. There's a good kind of like wide diversity of the our goods and bads, their pros and cons, how we work together. I might be a little bit riskier than them, and so we have a good spread, and we kind of keep each other aligned well. And then the rest of the team, like we've got Sam Hook, like he came over here from England for us. Andrea is a great hypersonics engineer. Anu, our GNC engineer. Haley's the newest structures engineer here. And we have 3 interns right now. Claire, Evan, and Sophia, who we got from the Z Factor Fellowship, a great program that if anybody's, in space or aerospace and interested in pretty much like cream of the crop interns, I would recommend them to work with them.
You know, we've talked with a lot of companies about the ability to hire talent that is ready to work in space. Are you finding, and I don't know if you're down to that level yet, because it sounds like you've got a bunch of highly technical people that you're working with, but do you see that the education chain is keeping up with the technology and the kind of people that you may need down the road as you grow your business?
I think it is. There are a lot of schools that are opening up or already have opened up really high quality space programs. And some get really, really particular into very niche areas that are really, really important for current space industry. Some do it better than others. I think if there's one thing that can still be improved, I'm not exactly sure if I have a perfect solution, but it's just like, I think we just need more hands-on education in general. Sometimes that's a funding aspect as well. Yeah.
We're just about out of time, Ryan, but I want you to look out over the next 10 to 15 years in space commerce and the role of your company, and tell me what you see.
We're looking kind of in the mid 2030s. We want to be launching, once to twice every week, bringing down next generation materials. We want to make it such that nearly anybody can get to space and back if they have an idea for research, or maybe they just want to send anything. We're also looking at delivering products to space anywhere on Earth. This is space to Earth cargo delivery. We can get stuff there not just in a day, but in 90 minutes. So, in the future, it could be that maybe you want to ship something and you want it to be there like now. And because the launch infrastructure is placed and the reentry infrastructure is placed, like you can do that. You can ship something halfway around the world within just a couple hours. But then also there's going to be new drugs to rare diseases. We're going to have just kind of healthier lives. We're going to have better computers, better chips. You're going to have better ways to communicate with each other. And that's all going to be because of products that are manufactured in space.
Since what it is that you're doing kind of relies on these private space stations that are under development, and some of them have some pretty aggressive timelines to be able to get into orbit, do you feel like you're in a good place to be able to get your business off the ground, for lack of, if you'll pardon that pun, and work with those companies that are developing those private space stations?
Absolutely. When these come on, and I think, right now the earliest 2026 and 2027 and 2028 is when I think most of them are planned to come online. It's going to be a great time because we'll have a qualified fleet of vehicles that are ready to fly, ready to integrate with a variety of different rockets. And we'll also have our rendezvous and docking technology kind of qualified and operational, which is a rare thing these days. So I'm really excited for that. Off sequence or off cycle cargo return is a big thing for the upcoming space stations.
Ryan, we're out of time. Thanks very much.
No problem. Thank you. It's good to be here.
Ryan Elliott is co-founder and CEO of In Orbit Aerospace. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Google Podcasts, Audible, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss any episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo. The proof is looking glass. That's for reason. Our dreamer's eyes we gaze into a sense of purpose, known by view. Like finding water on the moon.